chip soldering, BGA soldering, hand soldering, and more. That's what we are going to have a look at in this video. First, BGA. BGA is a chip with balls from the bottom. It looks like this. I took one and placed it on PCB, and we are going to heat it up. When you place BGA on PCB, you need to be sure it's placed correctly. The balls, they need to be above the pads. And when we increase the temperature, then the balls will melt. And it's very cool to see what will happen when we decrease the temperature, when we cool down the chip. Wow, this was really, really interesting. And this is how it looks when BGA is soldered down. Now, I created this experiment where I placed the BGA wrong way. You can see the balls are not above the pads. And this is what will happen. Now, this is a standard chip. This is what many people know. And this is how it is soldered down. So we applied this solder paste. And if you have ever seen solder paste, maybe you never noticed, it is actually created from these very small balls. It looks like this. And then when we heat up this solder paste, it will melt and the chip will solder down. Okay, and then it looks like this. It's always very interesting and important to double check the quality of soldering, and you can see how the solder climbs up the legs, and some specifications, they will actually tell you how much it should climb up. Again, another experiment. I placed too much paste. You can see there is no space between the pins and pads, but this is what happened. It actually soldered quite well. There are some bridges or short circuits between some of the pins, but many pins, they are soldered properly. However, notice the small balls all around the PCB. So this is not good. This has to be cleaned properly. And also maybe when they are doing this kind of soldering, it's very important to set up temperature profiles. This is different kind of chip. Again, we need to place it nicely above the pads on the PCB, and when we heat up the PCB, this is what will happen. Watch how the solder climbs up the pins. Very nicely soldered. Always when you do this kind of soldering, double check all the pins if they are soldered properly. You can also do some measurements, double check if this is good for soldering. And there is also this cool 3D view which can be created by this microscope, and you can also do all the kind of measurements in this 3D view, like create this profile, height profile, and then you can measure at any point you want. This is something what I was very surprised to see on this microscope. Now, another experiment. There is too much solder on the middle pad, and also I placed there like quite a lot of flux, but this can be sometimes problem. A lot of flux may be sometimes problem because of the bubbles, but the biggest problem here will be a lot of solder on the middle pad and not enough solder on some of the pins, some of the pads. notice how they will be soldered. So we are heating up the PCB, and notice some of the pins will be soldered properly and some of them will not have enough solder, so you will see they will not be correctly soldered. Can you see it? Now also you can see there is a lot of flux which went up when the chip went down, and so this is not very well soldered. But I wanted to show you this experiment because this may sometimes happen when you do this kind of soldering at home. And this is how it looks when it is soldered in production. So this is the proper soldering. And this is hand soldering. So this one is leaded soldering. And I wanted to do leaded and lead free so you can compare how they look. So now I'm going to do lead free soldering. Okay. It melts at a little bit higher temperature, but notice difference in the structure when it cools down. Notice how it will look. See? Probably when you ever seen these two together, you always notice the difference. The lead-free is a little bit different. The leaded is always kind of shiny. This was again experiment. I tried to put too much solder because sometimes depends on experience how people solder down components. Sometimes they can put there too much solder, so I wanted to create this example so you can see how it looks. I'm still going to put there a little bit more. Oops, there is this short circuit, but it was easy to fix it. And I'm still going to put there a little bit more, so it looks even better. Like, have a look. I'm going to add like this. Cool. So this is too much solder, and I have one more example included in this video. Actually, I created much more examples, but this is the last one in this video, and it's like too little solder. I've seen this a couple of times. These are all the kind of examples which I tried. And this is how it actually looks. So this is the setup what we used. You can see the microscope. And right now we are looking at PCB, multi-layer PCB. I cut it in half so we can see the layers inside of the PCB. I just thought it looks really cool, so I wanted to do this when I had this microscope available. And I was curious if we can see the copper foil. Maybe it's this, and this may be the plating, but it's not very clear from this picture. I was just curious. And this is the last view, and I included it in this video because I just found it cool and interesting. If you would like to learn more about electronics, don't forget we have online courses, and I do many videos about how to design boards and about PCB layout and EMC and all the kind of topics related to electronics. So don't forget to check out my other YouTube videos. Thank you very much for watching, and see you next time. Bye.